Hello everyone. In this video, we're going to be solving a homemade exponential equation. These equations are not hard to make. If you looked at similar problems, you can probably make one of these too. So we have an equation that we're going to be solving for integers, which means it's a Diophantine equation. We have 2 to the power m minus 2 to the power n minus 2 to the power k equals 95. M, n, and k are integers. So let's go ahead and take a look at it from a parity perspective, which means the evenness and the oddness perspective. So powers of 2 are pretty much even numbers. So when we have even minus even, that is even, right? You can easily prove that. And if you subtract another even number from it, the answer is going to be even again. So no matter how many evens you subtract, you're always going to get an even answer. But guess what? 95 is not even. Right? Not even. So how is that possible? This is kind of odd, right? Well, 95 is odd and it's really odd. So how is this even possible? Well, here's the thing. 2 to the power 0 equals 1, and that's an odd number. So that's the key. Well, is 2 to the power 0 a power of 2? Well, in some sense, yes. So 1 is actually the only power of 2 that is not even. I'm not talking about obviously fractions like 1/2 or 1/4. We're talking about integers here. All right, so let's go ahead and assume, and we could kind of use that, familiar phrase without loss of generality. Let's just assume that k equals 0. Now, the reason why I said that is n and k are interchangeable. So, but we're going to assume first k is 0 and suppose they are arranged from largest to smallest, and then later on we can take care of the switches. All right, so in order for this difference, or whatever you want to call it, to be odd, one of them has to be odd, and we're going to pick k equals 0. Okay, great. So if k is equal to 0, we get the following. We get 2 to the power m minus 2 to the power n minus 2 to the power 0, which is 1, equals 95. And from here you can safely see that 2 to the power m minus 2 to the power n is equal to 96. This is normal, right? Because the difference is supposed to be even most of the time. Now, we're good. Now, how do we solve this equation? We've done a similar problem before, by the way. I think that was a competition problem from Russia, as far as I remember. But the result, the difference was huge. It was, I think, 1,984 or something like that. Anyways, the idea is the same. And in this case, we can see clearly, hopefully, that m is greater than n, right? Because their difference is the 2 to the power m minus 2 to the power n is positive. So let m equals n plus t, where t is a positive integer. Okay? All right. Now let's see what happens if we make this substitution. Replace m with n plus t. You get 2 to the power n plus t minus 2 to the power n equals 96. And I know at this point a lot of folks are saying, hey, I already got the answer. Okay, great, but we're just going to solve it algebraically. Yes, definitely you can guess what it is going to be like. So let's go ahead and take out 2 to the power n here. So in other words, kind of factor it, because when you multiply two powers with the same base, and it also came up in a recent problem, you add the exponent. So we can also undo that. Now 2 to the power n is a common factor. Let's take it out. We get 2 to the power t minus 1 equals 96. Now this is significant because we're basically looking at two things here. One of them is a power of 2. All right, 2 to the power n. Remember, n is an integer and n is greater than k, obviously. So this is a power of 2, and this is 1 less than a power of 2. Okay? 1 less than a power of 2. So we'll kind of multiply two numbers and we get 96. So this is very unique. Let's go ahead and factor 96 into two factors such that one of them is a power of 2 all the time. If we don't know the second factor, we're not going to control it, but it's going to come up automatically. For example, I can do 2 times 48, and then I can do, obviously, we should probably start with 1 times 96, right? Because 1 was also considered a power of, but in this case, you can tell n is not going to be 0, but let's just write it. So 2 times 48 is another one, 4 times 24, and then we have the 8 times 12, and then we have the 16 times 6. And then you can also write 32 times 3. And I believe that is going to be it, because 64 doesn't go into 96. Make sense? Okay, great. So these are all the ways you can factor 96, such that one of the factors is always a power of 2. But at the same time, we also have to check that the other factor is 1 less than a power of 2. So if not, then we're just going to eliminate that case. For example, is 96 1 less than a power of 2? Think about it. How can you tell if a number is 1 less than a power of 2? You can add 1 to it, and if the result is a power of 2, then that number must be 1 less than a power of 2. For example, what is 96 plus 1? 97. Uh-oh, that doesn't look good. Okay, so we're going to eliminate this case. What about 48 plus 1? 49. Is 49 a power of 2? Uh-oh, no way. How about 24 plus 1, which is 25? Is 25 a power of 2? Nope, I don't think so. How about 12? Let's go ahead and add 1. 13. Nope, that's not the case. If you add 1 to this, 6 plus 1 is 7. Nope, that's not it. Wow, we saved it for the last. 3, if you add 1, you're going to get 4. And yes, 4 is a power of 2, which means 3 is 1 less than a power of 2. Okay? In other words, 3 is 4 minus 1, and 4 is a power of 2. So that gives you a unique situation here. And you can tell that 2 to the power n in this case is going to be 32. So we have 2 to the power n equals 32, and 2 to the power t minus 1 equals 3. Great. So from here we can basically find the values of n and t. Let's go ahead and find it. The first one gives us n equals 5, because 2 to the 5th power is 32. And the second one gives you 2 to the t equals 4, and t equals 2. But remember, our goal is not to find t, because t is just kind of like a dummy variable, right? Well, all of these are dummy variables, but anyways. T equals 2 means what? Let's go back and see what t means. Well, we assume that m equals n plus t. Let's go ahead and write it down. M equals n plus t. And we just found out that n equals 5 and t equals 2. Awesome. This just means that m is equal to 7. And when I said, yeah, I know most of you guys are already familiar with the answer, because guess what? 128 minus 32 equals 96. So binary is interesting because you can only write a sum of numbers in a unique way. So you pick any number, and of course that goes for subtraction too, but just pick any number, and there's only one way to write it in binary. That's kind of unique. All right, anyways, so we got the values. M is 7, n is 5. Right? What about the k value? Well, we had assumed that k is equal to 0, remember? So that kind of gave us 7, that kind of gave us the order triple, 7, 5, 0. But guess what? That's not the only order triple that works, because remember, we were allowed to switch n and k. Therefore, 7, 0, 5 is going to be another valid solution. So we got two solutions for this equation for integers. Can there be negative integers? I don't think so. If you think there are, and if I made a mistake, please let me know. Hopefully not. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.